And we said, if you're trying to find the sine of theta, what are you really looking for? The y. The y value of the coordinates. The cosine of theta was x, and the tangent of theta was y over x. The new trig functions are called the cosecant. CSC is for cosecant. If you need to write down cosecant, write it down so you know what it is when you're looking at it. The cosecant is 1 over y. We also have the secant, S-E-C, and that's 1 over x. And we have the cotangent, C-O-T, and that's x over y. Our 3 additional trig functions are tied to our 3 basic trig functions. How are the sine and the cosecant similar? They both have y. How are they different? How are the sine and the cosecant different? One of them's y and one of them's 1 over y. They're reciprocals of each other. Whatever the sine is, if you flip that fraction, you have the cosecant. Whatever the cosine is, if you flip that fraction, you have the secant. They are reciprocals. And whatever the tangent is, if you flip that fraction, you have the cotangent. All right? So even though now we have 6 trig functions, it's not twice the work, because you've done most of the work by finding sine, cosine, tangent. And then we're just going to be flipping fractions and simplifying them. The sine of 4 pi over 3 means I'm looking for the y value at 4 pi over 3. What's the y value there? Negative square root 3 over 2. Okay, let's do the cosine of 4 pi over 3, which means I'm looking for the x value. Negative 1/2. All right, and then the tangent of 4 pi over 3. Remember, tangent is y over x, and we've actually got to set that fraction up. So my y was negative square root 3 over 2, and my x was negative 1/2. So I have negative square root 3 over 2 over negative 1/2. And we're trying to simplify this by hand. So when you're dividing fractions, what's the phrase? Right. Keep, change, flip, skip, change, change. Y'all are talking about the same thing. So keep, change, flip. I keep the top fractions. So the square root of 3, negative square root 3 over 2. Change to multiplication. And flip the bottom fraction, so negative 2 over 1. The negative signs, by the way, they're just in front of the fractions. They're not attached to a number. So that's not a negative 2, and it's not a negative 1. It's a negative fraction. Now, when I do my keep, change, flip here, what can happen? The 2's cancel out. The negatives cancel. A negative times a negative is a positive. So we have positive square root 3 over 1, which is just square root 3. So my tangent is just square root 3. Which trig function goes along with sine? cosecant, CSC, cosecant of 4 pi over 3. Now, when you wrote that down, we said the cosecant was 1 over y. And I said it's tied to sine because it's the reciprocal of sine. So if we already know what the sine of an angle is, we just have to flip that fraction to get the cosecant. So if my sine is negative square root 3 over 2, my cosecant will be negative 2 over the square root of 3. Negative 2 over the square root of 3. That's not an acceptable answer. How come? Radical in the denominator. That's just a rule in math. We cannot have a radical in the denominator. How do we get rid of that radical? Multiply it by square root of 3 over square root of 3. It's called rationalizing the denominator. We're going to rationalize the denominator. So on the top, negative 2 times the square root of 3 would just be negative 2 square root 3. On the bottom in my denominator, I've got square root of 3 times the square root of 3, which is what? Which is 3. Square root of 3 times the square root of 3 gives me the square root of 9, which is just 3. So I have negative 2 root 3 over 3, and that's my cosecant. Which trig function is tied to cosine? Secant. So the secant of 4 pi over 3 is 1 over x, which is just the reciprocal of my cosine. So if my cosine is negative 1 over 2, what's my secant? Negative 2 over 1, which is just what? Negative 2. Okay, and lastly, we've got the tangent. Which trig function is tied to the tangent? Cotangent. Now, your tangent and your cotangent are normally the hardest ones. Not always, but they're normally the hardest. When I begin the cotangent, I'm going to look at my final answer for the tangent. Now, our final answer for the tangent of 4 pi over 3 was what? Square root of 3. So my cotangent would be 1 over the square root of 3, the reciprocal. If my tangent was the square root of 3, that's like the square root of 3 over 1. And I flip that fraction, I've got 1 over the square root of 3. Is that an acceptable answer? No. I need to do what? Rationalize it by multiplying square root of 3 over square root of 3. Okay, in the numerator, 1 times the square root of 3 is square root of 3. In the denominator, square root of 3 times square root of 3 is 3. Okay, now negative 5 pi over 6. What should stand out about that angle? It's negative. Okay? Now, if you're trying to find a negative angle on the unit circle, first look at the positive. Where is positive 5 pi over 6? Yeah, at the 150 in my second quadrant. So positive 5 pi over 6 is moving from my initial side all the way over here. We've been working on the unit circle. Negative 5 pi over 6 would be going the same distance in the opposite direction. So I would land right here. You can also reason through it. Your negative angle is really just a reflection. If 5 pi over 6 is right here, and I reflect it over my x-axis, negative 5 pi over 6 is right here. So when I say negative 5 pi over 6, what positive angle are we really talking about? 7 pi over 6. And I'm going to write that equals 7 pi over 6. That way, as I'm working my problem out, I don't get confused and start looking at 5 pi over 6. I'm going to look at 7 pi over 6 because my angle was negative, and that's really the location we're looking at. All right, so the sine of negative 5 pi over 6, the sine of t. Remember, negative 5 pi over 6, we said, was right here. For the sine, I'm looking at the y value. What's my y value there? Negative 1/2. Cosine of t, I'm looking for the x value. Negative square root 3 over 2. And then the tangent of t, y over x. So I've got to set that fraction up. My y was negative 1/2 over negative square root 3 over 2. How am I going to simplify that? What's the phrase? Keep, change, flip. Keep that first fraction intact as it is. So I'm going to keep negative 1/2. I'm going to change to multiplication. And I'm going to flip that bottom fraction. I'm not changing any signs. That's why I'm using keep, change, flip. I'm not changing any signs. So the bottom fraction stays negative, but it'll be 2 over the square root of 3. When I do that, what's going to happen? The 2's cancel out. The negatives cancel out because a negative times a negative is a positive. So I end up with positive 1 over the square root of 3, which you have to rationalize by multiplying square root 3 over square root 3, which will give us the square root of 3 over 3. So our final answer for the tangent was the square root of 3 over 3. Okay, so half the work's done. That was the hard part. Which trig function is tied to the sine? Cosecant. So let's find the cosecant of t. If the sine was negative 1 over 2, what's the cosecant? Negative 2 over 1. You're not changing positives and negatives. You're just flipping fractions. So my cosecant is just negative 2. Which trig function is tied to the cosine? Secant. Now if my cosine was negative square root 3 over 2, what would my secant be? Negative 2 over the square root of 3. And rationalize it. Times square root of 3 over square root of 3 gives us negative 2 root 3 over 3. Alright, and what's our last trig function? Cotangent. So the cotangent of t. If my tangent was the square root of 3 over 3, then my cotangent is what? 3 over the square root of 3. Rationalize it. And what do we get? 3 square root 3 over 3. What do you notice about that answer? I can cancel the 2 3's and I've got the square root of 3.